Hello friends! Today we've created a smart 12-volt battery charging protection circuit. This circuit is designed to automatically stop charging once the battery is fully charged, protecting it from overcharging and extending its overall life. So let's first take a look at the complete making process. We'll do a full testing to see how the circuit performs in real time. Friends, for this project, the PCB I used was designed with the help of a trusted and high-quality website linked to JLCPCB.com. This platform is especially great for those who work on electronics projects and need professional-grade PCBs for their circuits. I personally ordered my PCB from JLCPCB, and I must say the quality was really impressive. All the pads, tracks, and layer alignments were perfectly done. The best part is you just need to upload your design and they will manufacture and deliver your PCB straight to your doorstep. That too with really fast service. I highly recommend checking out their website. I've added the link in the description. Just click it, explore, and experience the quality and service of JLCPCB yourself. To build this circuit, I've used a combination of essential electronic components like a power transistor, IRFZ44NW, which is known for its high current handling. Along with that, I've added a 10K preset, which is used to manually adjust the sensitivity. I've also included a push-button switch core, which acts as a manual trigger or reset option in the system. I've used two pieces of the 1N4007 diode. These are standard rectifier diodes that help in current direction control and circuit protection. I've chosen a 1K ohm 1/4 watt resistor, which limits current to protect the LEDs and other components. Speaking of LEDs, I've installed 3 red LEDs, which serve as status indicators during the working and testing phase. The main control of the circuit is handled by a 12 volts relay, which plays a vital role in switching the output when triggered. All of these components are carefully placed and soldered onto the PCB. I've already completed all the soldering work, ensuring every joint is clean and properly connected. Friends, if you look closely at the circuit board, you'll notice 3 label sections printed on it. One labeled as battery, with terminals marked battery plus and battery, and another labeled as load with load plus and load markings. I've used a 19 volts power supply, which is a great voltage level for charging standard 12 volts batteries efficiently. It is showing a reading of around 19.7 volts, which is a very stable and sufficient voltage for charging. Always make sure that the negative wire from the battery goes to the negative terminal of the circuit, and the positive wire connects only to the positive terminal. A wrong polarity can damage your circuit or prevent it from functioning entirely. In this circuit, we've set the preset to cutoff at 14 volts. This means that as soon as the battery voltage reaches 14 volts, the circuit will automatically disconnect the light or output, effectively preventing any risk of overcharging the battery. On one side of the circuit, we've added a push button, and that serves as a manual reset switch. If at any point you need to restart or reset the system, just press this button and the circuit will reset to its initial state. Now, without wasting any more time, let's move on to the quick testing. I've already connected the multimeter probes to the battery terminals, and as you can see on the display, the current battery voltage is around 3.2 volts. Next, the moment we do that, you'll notice that the voltage on the multimeter starts to gradually increase, which clearly shows that the circuit has entered charging mode. This proves that our circuit is working perfectly. It's not only responding correctly to the input, but also regulating the voltage just as expected. The reset system is functioning as well, and overall, the circuit has passed the testing phase successfully and is now ready for real-time use. So friends, today I showed you how to practically make a 12 volts battery protection circuit. I've tried to explain everything clearly in a simple way, so even beginners can easily understand how the circuit works and how to make the connections properly. I hope all the points were clear to you, but if you still have any confusion or doubts, feel free to ask in the comments below. So that's all for today's video. See you in the next video with another interesting project. Until then, bye-bye and take care!